Hi, my name is Baron Fong. I am the Research Director at Dell'Oro Group, responsible for our coverage in data center infrastructure, with specific emphasis on compute and server connectivity. Dell'Oro Group was founded in 1995, and we are headquartered in the Silicon Valley. We are regarded as the gold standard in the industry for market information related to telecommunications, enterprise networks, and data center infrastructure markets. Today, I would like to talk about a white paper that we are working on with a special emphasis on the latest trends and innovations related to the green or sustainable data center. Next, I would like to hand off to my colleague Lucas for an introduction.
Thanks, Baron. Hi, my name is Lucas Barron, and I'm a principal analyst at Dell'Oro Group, leading our data center physical infrastructure research. So when I say physical infrastructure, I'm talking about facilities infrastructure, such as UPS, power distribution, thermal management, and the software and services to maintain and manage that infrastructure. And while data center physical infrastructure is a smaller portion of data center capex relative to IT infrastructure, it actually accounts for up to half of a data center's operational energy use. That means that when you're setting or thinking about sustainability goals for your data center, there are significant considerations and opportunities to address that through your physical infrastructure decision making. But before talking about more specifics on data center sustainability, I'll hand it back over to Baron to provide an overview of the greater data center ecosystem and industry trends.
The global pandemic and recent events have accelerated the digital transformation for businesses and consumers. Enterprises are adopting a more nimble and resilient hybrid and multi-cloud strategy, while consumers are embracing more online applications and content than ever before. As a result, we are predicting a strong sustained growth in global data spending, upwards of up to 10% CAGR over the next 5 years. We will continue to see the major cloud service providers and enterprises expand capacity in both the cloud and the edge. New server and network architectures will evolve and will enable greater efficiencies, automation, and in particular, the adoption of more AI workloads. We expect these new architectures will need additional considerations on the sustainability aspects of the data center infrastructure, given their demanding power delivery and consumption requirements. To talk more about data center sustainability and implications for future growth of the data industry, I will hand it over to my colleague Lucas.
Thanks for that overview, Baron. So, as the global COVID-19 pandemic accelerated digital transformation, driving data center growth throughout the past 18 months, it also cast a large shadow on the growing climate impact of data centers. This led to regulators, investors, and customers of data center services demanding more action on sustainability. In response, the data center industry began setting aggressive sustainability goals focused on increasing adoption of renewable energy, increasing data center energy efficiency, while also reducing water usage and achieving carbon neutrality, with target dates as early as 2025 and more commonly 2030. The first step in achieving sustainability goals is to evaluate what sustainability metrics we should be using to understand how sustainable our data center footprint is today and how we can measure our progress towards longer term sustainability goals. Traditionally, PUE, or power usage effectiveness, has been the primary metric to measure a data center's efficiency, which has loosely correlated with sustainability. However, with the evolution of the sustainability landscape to incorporate data centers' water usage and energy reuse, new metrics such as WUE, water usage effectiveness, and ERE, energy reuse effectiveness, are becoming increasingly important to measure a data center's holistic sustainability impact. Additionally, sustainability is expanding beyond Scope 1 and Scope 2 greenhouse gas emissions, or the emissions generated from the direct day-to-day operations of a data center and through the indirect purchase of electricity. Scope 3 GHG emissions, or indirect emissions related to the upstream and downstream supply chain of a data center, are coming into focus. This is requiring manufacturers of data center infrastructure and operators of cloud, colocation, and enterprise data centers to work together throughout a data center's entire lifecycle, from planning and design to construction, operation, and maintenance, to optimize the performance and sustainability impact of the growing data center industry. Finally, we'll explore use cases where sustainability best practices have already yielded significant cost savings and reduced carbon emissions. For example, we'll explore an instance where a 3,000 cabinet data center, utilizing sustainable technologies and practices, was able to reduce PUE from 1.6 to 1.3, resulting in annual electricity savings of 38 megawatt hours and carbon emissions of 2,860 tons per year. Stay tuned for the publication of this white paper, where we'll expand further on these topics we covered in this video, from data center industry trends to a detailed overview of sustainability metrics and best practices to enable further development of data center sustainability. We hope that after reading the paper, you'll be better positioned to take action and engage in conversations to support the further development of the data center industry's journey to a sustainable future. Thank you.